Good day, everyone. Welcome to the part 2 of our Prota structure training. I remain your facilitator, Engineer Kazim Seidu. Now, I believe everyone has already watched the first part, which we shared the video link in our Telegram group. Well, this is the second part now. I believe by now everyone has already known how to create axis and do some field settings. Now, before I go into modeling and doing my structural analysis and design, I always like to do my design settings, which is what I would encourage you to do. Do your design settings before you even start modeling. This will save you from a lot of things, and it would save you from different errors. You wouldn't want to imagine a case where you already finished modeling and you just rush to designing analysis without your proper design settings. So now there are design settings we would go over now, which are the slab design settings, beam design settings, column design settings, foundation design settings. But before those mentioned, we would also go back to our materials, which I've shown us in the previous video. So what we'll do now is go to our analysis, building analysis, then we'll go to our edit materials. What I want to do here is to specify some material that I want to be available for analysis and designing. Because here, if you don't specify maybe some kind of reinforcement that should be available for the software to pick from during designing, you might have some unnecessary reinforcement types in your elements which you don't want. So what do I mean by that? Let's go to our concrete columns first. Go to rebar diameters. You can see here on this column, we have 5 columns here. We have the label columns, we have the diameter column, we have the hook length column, the area column, and the use column. Now under the use column, this means that any reinforcement that is selected here would be available for the software to choose from when it is designing. So when it is designing the concrete column, if during the designing it feels that white 10 would be suitable for a particular column section, it would select white 10. If it believes white 13, which is actually not really available anywhere in Nigeria, it will select it. Now, would you want your structural details to contain reinforcement that you probably don't want or that are not available? For instance, we all know for concrete column, we generally use Y16 in most cases. Now, if maybe peradventure I want Y12 to be available, then I will probably want to select Y12. If you don't select Y12, then even if the software during the designing feels Y12 should be suitable and it is not enabled for it here to choose Y12, then it will not make Y12 available. It will rather go for something higher or something lower if that would satisfy the condition. Now here, I want, in my own case, for the purpose of our lecture, I want only Y16 to be available for column design. So what I do is, let me select everything and unselect to clear all selection that might have been selected. Now I want to choose only Y16. Choose that, press OK. For concrete walls, I want Y12 and Y16 to be available. Now this is how you do for every structural element. You can also do this if what you want is a particular set of reinforcement, probably Y12 and Y to be available for all structural elements. You select the two, select all you want to choose, and just click on apply to all members of this rebar class. Click OK. By the time we go to concrete beams now, that we have not even been there before, you would only see those two selected available. Every other selection would have been cleared. That's because we chose apply to all members of this rebar class. If we go back to our concrete columns, which we only chose 16 mm at a time, if we go back there now, we see Y12 has been selected because we chose apply to all members. So I believe you understand what that does now. Let me choose to leave that. So that's how you choose for all the structural elements that are going to be available in your structure. Same thing go for foundation. For foundations, let's check our bar. We don't want Y12. I don't want Y12. Select OK. For links, probably I want Y10 to be available for the links. This is what I want. I don't want Y16 for links. I want Y10 only. Select OK. So that's that for the materials. Press OK and just close. That's how you edit your materials. Now, another thing we want to look at is our loading combination. Loading combination is also on our analysis menu here. So let's go to analysis, building analysis. Then go to our loading combination. This is important for you, for every project, you have different loading combination. There are some projects that would need you to include wind loads. So to do that, there is where you generate your loading combination automatically. So let's go to loading generator. You already have it here. You have the vertical load combinations and you have the horizontal load combinations. This is where you can actually specify your wind loading if that is required for your current project that you are designing or you're working on. You select it for it to consider adding the wind load factor according to the BS standard. For our own purpose, I would not be including that. I also have the vertical loading combinations. Here, you're probably not choosing anything or changing anything. You have your G factor, which is your dead load factor, which is 1.4, your live load factor, which is 1.6. So all you have to do is just press OK, then you see everything being generated, all possible combinations. The software will do that automatically. So we've done that. Then press OK. And that's all about the loading generator. Now the next thing is for us to go into our design settings for our structural elements, the columns, the beam, the slab, and the foundation. Now the first one we'll go for is the column design settings, which you can access through the settings menu. Go to settings, column design settings. Now you're presented with these settings and parameters window. The first tab there is the design tab. In most cases, you are changing nothing here because why? Most of the settings there, the code settings, the BS code, all the requirements and the BS code will be adopted in this section except otherwise stated by you. If you have some special case that you feel the need to change anything here, so you will not be changing anything here in this minimum steel percentages. It will adopt what the BS standard specifies. And also under the design tab, you have the parameters tab. Here is also very important. According to what you've learned in the Telegram group, in the column design setup, when you are designing for your columns, we talked about the biaxial and axial bending. Now, the software already has the option stated here, where you can actually choose if your column should be designed as biaxial or use a particular clause from the BS standard, which is the clause 3.8.4.5. I would implore you to read that particular clause from your BS code, which you have downloaded, and you should have a copy by now. Also, under the design ultimate axial load, it is also adopting this clause, which is also what I would suggest you always use. For better understanding of what the clauses say, you should read your code and check for this clause in order to understand why the software is adopting this clause or why you might need to use the other option. So it depends on what you are working on. And under this biaxial bending method, if you choose biaxial, you are telling the software to design all your columns and you assume all your columns to be subjected to biaxial bending, which might not be okay. Instead, you go for this other option, which is the clause 3.8.4.5. This clause actually stated that it would design a particular column as biaxial if it is needed, if it deems it as biaxial loaded column. Now the next one we check is the steel bars. For the steel bars, we have different tabs under the steel bars. We have the selection method, the column containment, the wall containment, longitudinal bars, the links, and the mesh steel. Now for the selection method, what this is saying is how would you like the software to choose or to help you select your reinforcement. The pre-selected option here is the bar spacing maximization method. You probably could have maybe understand what it's trying to say here. Now it has some hint here below here to explain to you what the option that has been selected means. For the bar spacing maximization method, it means the program modifies the layout so that the steel bar sizes are maximized to achieve the maximum spacing within the range specified in settings between the bars. What does this mean? It's saying the program would modify the layout so that the steel bar sizes are maximized. That means the software would go for the highest bar size available, which you have specified. If during your materials editing you specified or you chose Y20 mm as one of the steel or one of the reinforcement to be available for your column design, then the program would tend to choose Y20 mm in its design at all time because this is bar spacing maximization method. So it will go for the higher steel size, higher reinforcement size rather. So now another steel bar selection method is fixed bar layout method. In this method, the program does not modify the steel bar layout in this method. Only the bar sizes are determined based on the given layout during design process. And you also have the bar size minimization method. This definitely, as the name implies, will go for the least size of reinforcement that you have selected. If Y12 is available, it would select Y12. But what does this the effect of all this is that if probably during your design in a particular column that you're supposed to use just 4Y16 mm, if you choose bar size minimization method and you also specify that Y10 or Y12 will be available for your column design, let's say Y10 is what you chose to be available for your column design, it may choose Y10 and provide probably 8Y10, 12Y10. That will just satisfy the total reinforcement area. And that is because you chose bar size minimization method, which says the program modifies the layout so that the steel bar spacing is minimized, and that would lead to higher number of reinforcement. I hope you understand that. So in my own case, I always go for the bar spacing maximization method, of which I already know I specify the highest steel bar size for my column should be Y16. Now let's go for the column containment. This is just a place for you to just specify in case it encounters different types of column, maybe a rectangular column, how it should arrange the links, how it should arrange the reinforcement. It's just this. So most of the time you probably work with what has been pre-selected, except where you want to change or how it looks. So it already has the condition prepared, the conditioning here, the b/h. When the b/h is less than 1.8, these are the parameters. When it is greater than 1.8, the parameters. Sorry. Now another one is the wall containment, more like the column containment, how the reinforcement should be arranged to be contained. Now you have the longitudinal bars. So this is where you specify your minimum and maximum reinforcement to be used in your design. This is where you choose that. And now for the column bar size, the minimum, the pre-selected one is Y12. I want my minimum to be Y16 and also my maximum to be Y16. What I'm telling the software here now is that I don't even want any other bar size aside from Y16 to be present in my column. If in your case you want Y12 to be present in a column that is suitable for, probably you want to minimize cost, and you just want it to, if it designs and it feels that Y12 satisfies the condition in a particular column, it should select Y12. If Y12 doesn't satisfy, it will go for Y16. But in my own case, I want only Y16, so I choose that. So if you have any wall, any concrete wall in your project, you also can specify the reinforcement here. Now it's also asking minimum column steel bar spacing at 25 mm, your maximum wall web steel bar spacing, your steel bar spacing step. The step works in a way in such a way. Although in column you would not notice this, you notice it more in slabs. You know, when you talk of steps, that means if during the design it encounters a particular spacing of maybe the spacing it's calculated is 100 mm. If it's going to try another spacing, it will be 105. The spacing step is 5. Let's say your spacing step is 50. If it tries 100 mm and it doesn't satisfy the condition, the next spacing it will try, if your step is 50 mm, it will be 150 mm. So let's just leave this in column. You probably will notice that. Now it's saying use, you can check or uncheck this, which is use similar bars as web bars for walls without end zones. Now the concrete cover, it's already stated here. If you leave 0 here in this input box, then it will use 25. Concrete cover of 25 will be used when 0 is entered. If you have a different cover you would like to use, you can enter it here, probably 30 if that's what you want. If it's 25, you can also enter into 25, or just leave it at 0 for it to use a concrete cover of 25 mm. So another thing we'll look at is the links for your column. Now remember when we're editing our materials, we specify that Y10 is what we want to use for all our links. So even if you click this drop down, the only bar size you would see available for selection will be Y10. So also you can also specify the minimum link spacing, which is 100 in column. The minimum link spacing for column is 100, and the maximum here is 300, which is also what is always advised and allowable. So 300 mm for maximum link spacing, and minimum link spacing is 100. Now here you have the link spacing step to be 25. What this means is that if during the design, the software, after designing, meanwhile I should mention that the spacing definitely will start from 300. You know, it will try the most economical approach. You know, when you have more spacing, you use less reinforcement. So if it tries 300 mm and it doesn't work, the spacing doesn't work, it doesn't satisfy, it will reduce to 275, then goes down like that in 25 mm spacing interval until it gets to the suitable or the satisfied link spacing. So with that, you can also check your detailed drawings tab, still under the column design settings. Here you have some settings that you can just do. Some are for labeling, such as this checkbox which says print column links segment length. So this, if you uncheck it during your when you want to produce your structural details, it would not have the segment lengths rather, so it won't indicate it, and such information might be useful for you, so you want to check it. You also have the single link type, how you want it to display the link in the detail, so in the detailed drawing. Also, so you have the column bar bob, here also you can specify your bob length and your starter bars length factor. If you have, probably you want your when your starter bars, most of the time before it connects to the other floors, you want if you use 0, the length will be calculated according to code requirement. But if you want a factor, probably you want it to be longer or shorter, you can also enter the factor here. Here I have the kicker depth also, which is 75 mm in most cases. And now you have the column details tab. Here is just for you to specify what you want and what you don't want to be displayed in your detailed drawing. Here you have the display steel bars to the right of the detail. Print steel bar detail length, print steel bar total length, display section below the detail. These are all information that you want on your detail drawing. You may choose not to have some by unchecking them. You may choose to have the section. If you don't want it, you uncheck it. So now in case we just leave it. And you can also set your scale, this drawing scale here. Also, there is also one thing here that you can use that would also appear in your detail drawing, the foundation penetration depth of length. In reality, you actually definitely your starter bars also would have length. So how should they penetrate? How much of it do you want it to penetrate? You can also specify. If you don't specify it here, it will also use the code settings as the case may be. So you have the column schedule. So this can be very, very important for your quantities because this would make it it will help you use that to calculate your column schedule, how much of reinforcement is needed for a particular element, and also you have more information to use in order to arrive at a different quotation for your project. So this is very important also for you to allow it display it on your detail drawings. And those are the major things in your column design settings. So just press OK when you're through with that. Now the next thing for us to do is to go for our beam design settings. Also access it through our settings menu, beam design settings, story beam settings. Now the first tab we notice here is the design tab, and the first parameter here that we want to look at is the design shear force. Now shear force actually the maximum shear force or the maximum shear stress rather occur at the ends of the simply supported beam. You understand? But in some code it's recommended that we should take it at a distance from the column face. So now what I would recommend for you is to take your design shear force at a distance from the column face. That's where the maximum shear force occurs. Now the second parameter is the section effective depth, which the software is asking you how it should take it. Should it take it from the center of gravity of steel bars or center of gravity of layers? Now the two methods are actually useful, but there are certain things you want to consider. Firstly, we understand that the effective depth of the beam is the distance from the tension steel to the edge of the compression fiber. Now, but in a case where you have two layers of steel, then it is the distance from the compression face to the center of gravity of the tension reinforcement. So now, in order to actually be able to consider every available option, so then it is advised to choose the center of gravity of layers. So another parameter is the interactive design. Interactive design, you are going to see what that is about by the time we are looking at our design, our provision, the output of our design and analysis. For the batch mode design settings, this is just asking you some things. When we're using batch mode means designing multiple beams at the same time, which is a bit different from interactive design. Also, we have these ignorable forces, and these are according to the code, which you can leave them as it is. You have the concrete covers, you have the kind of for the beam top edge, beam bottom edge, section side. If you have different values you want to set for all these quantities, then you can always input them. But if you want to use the code settings, which is a concrete cover of 25 mm, then you leave it at zeros. It will just use that as it is. Another thing we want to look at is the parameters tab. Here you specify your steel bars, the minimum beam steel diameter and the maximum beam steel diameter. I want to use a Y12 and Y16 as my maximum. For the wall also you specify the steel spacing, the minimum steel spacing. In beams you might not notice that for steel spacing. Also the bottom spacing, the steel spacing. These are things you might not notice in beams. So for the steel bar cut length, this is just like generally the normal steel length should be 12 meter, which is 12,000 mm. But when you get to the market, in reality, you hardly see 12 meter. Most of the time, you see 11.5, 11.7, 11.8. But for the purpose of your design, you could leave it as 12 meter, which is the correct steel cut length. Now, for the links also, we want Y10, which we have specified already. The maximum, the minimum is Y10 mm. So for the link spacing, you can change it here. If you don't want your minimum link spacing to be 100, you could put it at 150 or 125, as the case may be now. Also, just like we saw in column design settings. For your steel bar selections, you have the steel pattern. You have different patterns. You have from the standard pattern number 1, standard pattern number 2, standard pattern number 3. For the standard pattern number 1, you notice as you're changing, this place is also changing, showing you an illustration of what your detailing might look like. You have this pattern number 3. They have slight differences. For the pattern number 1, you have the lapping of the reinforcement happening inside the span of a beam. The lapping now happening inside the span of a beam. For pattern number 2, you have the lapping of reinforcement for different beams happening in the support. The lapping happening in the support here. That's what is happening here. For the pattern number 3, let me see, show you the specific difference here. So here it's almost the same thing as pattern number 2, but you have here it's for the compression zone now, it has the lapping happening in the span of a particular beam. So now, one good thing is that even after you produce your detailing, you can always come here to change a pattern if a particular pattern is not what you want. So in my own case, I like the pattern number 1 because I don't really want my lapping to happen inside my support. Also, there are some other settings. There are more settings that you can use. We say use at least 2 bars in second layer. So this is like saying provide nominal reinforcement for your compression zone for singly reinforced beam. And for these other settings, they use same bar size in first and second layer. Meaning, if you use Y16 in a particular layer, it will use Y16 in the second layer. Even if Y12 satisfies the condition in the second layer. You also have used same number of bars in first and second layer, meaning if you use 2 bars in a particular layer, it will use 2 bars in the other layer. If you use 4 bars in the particular, it will use 4 bars in the other layer, even if lesser number of bars satisfies the second layer. Another thing is a usage of 2 span bottom bars. So if you check this, it will use second bottom bars for 70% of the area of steel. Then one of the important aspects also is okay, the link, how you want the link to be. If you want this type of link, you leave it at which is the closed type. You have the open type, and you have the standard type. In my own case, I always like this standard type. It's economical and it's actually very nice to me. So it's what I use most times. So you can also check all other settings here. And now we have the curtailment. Yeah, these this particular settings, they don't really affect your design, but they would affect your detailing and how the preparation of your reinforcement on site would be affected. It depends. So it all depends on this. So if you say for the bottom bars, like you say lap bars inside support, you could choose lap bars outside support. You could choose extend lap into the support or extend lap into adjacent support. This is the most preferred for me. It's stronger and it might use more reinforcement, but it's very nice. So I use it most of the time. So for this settings, they match similar bottom span bars. What does this do? These settings, what it does is that if Y16 is coming from this particular beam, and Y16 is also for this particular section of the beam, instead of having a lap here, it would just go straight up. As long as the length of the reinforcement coming from here is not up to 12 meter, so it will still continue until it gets to a point where it is more than 12 meter. Then you have to lap another reinforcement. So that's what this does. If you say it shouldn't match, then it will have separate. It would have different reinforcement, different different cut length for different beam sections. So I always choose much similar bottom span bars. So if you say extend support bars symmetrically, if you can see a change in that. So in your design, most times a particular length might work for this section and another length for this section. So but if you want it to be symmetrical, you don't want it to be different. But having it different is very economical because you won't be cutting a particular length of bar when a smaller length of bar could actually work for this support. So but if you use if you check to extend it symmetrically, then you have this, and this is the factor affecting the support bar. So you also have these settings here also, which you can check. Then when you check that, you would actually see what it does. So let's check our detailing. Our detailing here, so this is for wall, which under the plot parameters, these are just general parameters you won't be changing. You won't be doing much of it there. So like just to display your axis, draw axis labels above everything. This is very important in your detailing for you to be able to pinpoint where a particular beam is on the beam layout. So you also have this. So these are your detailing settings, how you want your detailing to come out. If you say beam label list, it should display that or not. Print beam labels below detailing. If you uncheck that, this is how this would display on your detailing. But I always like it this way, so it won't be too it will be ambiguous. So you can also check display beam reference level. So this, if you check this, it will tell you at what level is this beam. When you have this, it will let you know the elevation of the beam, where it is in the building. Let's say you have a 3-story building or a 4-story building. This would help you know where this particular beam is in the building. You have the sections. How do you want it to display your sections? So do you want it to display sections for different parts of the beams, or you just want those sections, or you want all beams? So if you choose all beams, it will touch all the beams and give you all the sections. Your detailing now might be enormous. You might have a lot of unnecessary detail in your detail reports, in your detail drawings. So most times I do choose different beams for you to just consider some important parts of the beams. And the number of sections, do I want you to check for sectioning in the support areas or just the span area? If I choose the span area, it has only one section. It will just section it here and show me what is happening there. But it's good to choose the support and span section, because sometimes you might have a different reinforcement towards the support here, which is different from the span reinforcement. Because just like you learned while checking for bending moment, the moment in your span moment and your support moment. So you might have a different reinforcement in the support region, which is different from the span region. Your steel bar, the links, how we should label them is what you have here. So I won't be going over all that, so you can always check and see how it's displaying. Same with your sidebars and your dimensioning. So these are more like CAD settings that you can always do on your own. So that's all I'll be going over on the beam design settings. So you click save after you are done with the settings. Now let's go over our slab design settings. Go to settings, slab design settings, and go over the few important parameters here. You can see your concrete cover. A concrete cover of 25 will be used when 0 is entered. So, but I want to change my concrete cover to 20. Now, another important part is that the slab span length in analysis. So how do you want it to use it as analysis? Is it to use the clear span, which will be from beam to beams, or you want it to use the center line span? So the center line span is the most advisable to use. So you choose that. Let's check the steel bars tab also. Is where you specify your steel bars to be selected for the design. So the minimum steel bar size is 12. That's the maximum. That's why this 16 mm is showing, because when we're editing our materials, we allowed it to choose 16 mm. If we don't want it to choose 16 mm under no condition, that we want only 12 mm to be available for our slabs, then we can go back, edit our material to make only 12 mm available. Let me illustrate that now. Let me just press let me just cancel. I'm going to building analysis. Now just click on edit materials, then go to my slabs, the rubber diameters. So I don't want 16 to be available for slabs, so I will check it, press OK, then close this. So now watch, if I go back to my slab design settings now, under steel bars, if I check this drop down, 16 mm would not be available anymore. So that's the effect of that. So we have our bar spacing. You want your minimum spacing to be 100, maximum to be 250. If you want yours to be 300, you set it here. The spacing step, like I explained earlier in beam and column, the spacing step is when it's designed, it tries 250, which is the maximum, to see if it's satisfy the conditions, satisfy the deflection. So if it doesn't work, it reduces it by 25, meaning it will try 225. If 225 doesn't work, it tries 200, and so on until it gets to the minimum. So we have the steel bar length step. So these are things you probably want to check in order to fit into your project. So you have the containment make bob for top steel, for cantilever. This is important, this is necessary. So another thing is just the view. This has to do with labeling. This has to do with labeling. If you wanted to hide the number of bars in being labeled, which I would not advise you to do that, because if you check this and hide the number of bars, then you would not be seeing your complete details. You won't be seeing the number of steel bars it is providing for a particular slab section. So all it is also an optional thing to do. If you want to print alternative layer information like B1, you want to replace your B1 or to BB, which is bottom, BT bottom top, TT top, TB top bottom. So let's press OK. Now those are the settings that you want to go through. Make sure they are in order. Another thing I would want you to also check is your story height. You have different stories out, and this can be very useful, even especially when you are working with elements that are not of normal story height. Like in your building, you probably want 3 meter height, but you might be working with a structure that has its height more than 3 meters. So you just come to your story, right click on this story and click on edit story. So here you can set a story height, which is the elevation of the story. You can always set that here. Yeah, for the foundation design settings, I'll be showing you two places that are of concern. The first is we'll go to analysis, building analysis, and then parameters. So under the parameters window, we go to the foundations tab. Here you can set your allowable stress of soil, then the soil subgrade coefficient. You can, if you have a value, you can just highlight it and enter your value, or you can also check the range of specific soil types here. When you click on select, you have a different soil types with their upper limit value and the lower limit value. So you can see that you can always choose anyone that is applicable to your project. So for the purpose of this training, I won't be changing anything here. So you can close this tab. The second is going to our settings and select foundation design settings. So here also for the purpose of this training, we'll be designing part foundation. So most of the values here are for part foundation. So firstly, you have the soil stress ultimate strength factor. You have the soil unit weight. You have the surcharge height, link concrete thickness. You have your strip footing cantilever length and your default footing depth. Here you can also change it in some cases. You might have more than 500 or lesser than 400. 400 is the more commonly used default footing depth. Also, you have your default pad footing form, is either it's a rectangular or square. If it's square, then you're going to have the software providing for a footing type that would have the same dimensions in both directions. So let's leave it at rectangular. It can be economical than square. So now you also have the minimum coefficient, moment coefficients for span and for the supports. So these are in the design area here. You probably be changing much of it. You have your concrete cover. Here you'll be able to supply the concrete cover you're willing to use for your foundation. You could use a 50, 40, 70, depending on the nature of the area. The kind of concrete cover you would use in a swampy area would be very different from what you use in a dry area. And as it's stated underneath here also, it says concrete cover of 100 will be used when 0 is entered. So be sure to enter your desired concrete cover. So you also have this area where you set your steel bar selection, the minimum steel bar size, and the distribution bar size, which are 16 mm in our own case here. So let's press OK. So that's it. That is all about the design settings that I want to go over, and I believe we've been able to learn one or two things.